Did you know that it's recommended to conduct a measurement to prove that a collaborative robot is safe and correctly implemented for a specific application? To help any robot user, the COVR project developed so-called protocols, which are a step-by-step guide for how to make these measurements. In the following video, we are going to look at the protocol Test Robot Arm for maintaining a safe distance to humans. The specific purpose of this protocol is to validate the safety skill maintain safe distance by measurement. Its scope is limited to robot arms used in manufacturing situations. Let's look at a typical hazard during a collaborative scenario featuring this safety skill. A robot picks boxes from an assembly line and puts them onto a desk. At irregular intervals, a human enters the workspace to get one of the boxes. In this case, the workspace of the robot is enclosed by fences on 3 sides. On the 4th side, laser scanners are used to safeguard the workspace. The laser scanner is coupled with the robot's control unit in such a way that it initiates an emergency stop when a human enters the workspace. Possible hazards include that a human enters the workspace while the robot is still moving. In this case, the human could be seriously injured by the robot. Therefore, the robot must stop before a critical minimum separation distance is crossed. To ensure that the safety scanners are properly parametrized and placed, the COVR protocol, Test Robot Arm for maintaining a safe distance to humans, is used. For the test setup, we need to measure the braking and reaction distance of the robot after the safety system detects an intrusion. In this protocol, we use a wire encoder to measure the one-dimensional distance and a flag actuator to trigger the sensor. Both are connected to a control unit, which executes the measurement. The wire encoder must be placed at the position where the human could enter the workspace. The loose end must be fixed at the position on the robot surface with the minimum distance and highest velocity. In this scenario, this is the end effector. Next, the flag actuator must be placed such that it reliably triggers the safety sensor. Before we start testing, we have to configure the control unit. Make sure to choose the correct values for the minimum separation distance, the position uncertainty, and the speed of the entering human. Next, choose the appropriate part in the robot's program where you want to test. Now we can start testing. The device used in this video first records the movement without a safety stop. Then, the user selects the point in the trajectory where the flag actuator should trigger the safety sensor. Now the actual test starts. The robot starts moving, the flag actuator is triggered, and the laser scanner initiates an emergency stop. Next, the required safety distance is calculated by the control unit, and the operator compares it to the actual position of the safety sensor. In case the distance is sufficient, repeat the test at least 10 times. If they are not, the robot's velocity must be reduced, or the settings and positioning of the sensor must be adjusted. This was an example of how you can ensure the safety of your collaborative robot with help from COVR. If you wish to learn more, visit www.safearoundrobots.com.